Hello, welcome to Topper Machine. I'm Josh Topper. So today's job is this. This is a little axle shaft with a wheel on it that the customer brought me. Obviously, hadn't been seeing lubrication in a while, both bearing places. And this is all stainless steel. The wheel is welded to it. This is what I can see here. So we'll have to machine the welds off, get this off the axle, and make a new axle, put the wheel back on, and weld it back in place. So the first thing I need to do here is try to get this key out. Let's see if we can get it to move. Oh yeah. Nothing to it. And that, hopefully that bearing will slide right off. Yep, that's shot too. Now we'll go ahead and get some measurements of this thing, figure out where the wheel gets placed, and we'll just cut the welds and get that wheel off and then start making the new shaft. All right, so I got it cleaned up a bit and I got my drawing here. It's kind of weird. There's wear everywhere. It's coming out closer to 38 millimeter, just a little under that even, but they're running 1.5 inch bearings on this, so we're just gonna go with the 1.5 inch shaft just to make it work good. But look at all this wear here. There's wear here. There's wear here. This is or it's machined down, I don't know. I really don't know the whole detail. So we're just gonna make it a straight shaft, and if there is details that these things actually, you know, need to be like this, then they can bring it back and we'll just finish it up. But the reason we're doing this is this axle with the wheel on it is $2,700. That is ridiculous. This wheel is just fine. There's nothing wrong with it. We'll just cut it off, get it out of there, put a new shaft in, and get the customer back up and running for maybe a few $100s instead. All right, so because this thing is in such bad shape, I'm actually going to start on the bad end and just chuck it up, and we'll use the center because there's a center drilled hole and tapped on that end. We'll use the center to help align everything, and then we'll get the weld cut on this side and flip it around and do the other side. That'll give us the most stability. All right, let's just see what this thing looks like. Oh, that ain't bad at all. All right, so I'm just gonna come in with my regular cutting tool here. Just cut into that weld, work my way in. And I'm undercutting that shaft a little bit. So we want to be past the welds, so. All right, I'm going to turn my tool just a little bit to get a little more inward. Because I don't want to take too much of this surface, but it almost looks like we might have got it. All right, well, I'm hoping I'm below the weld enough. The hydraulic press will make easy work of this. But we're going to take the back side and we're going to cut that a little better, a little deeper, because that side's really messed up. And then we should just be able to pop it off this way. Wow, that thing really does not run well. Let me try turning it just a little bit in there, or reposition it. In fact, maybe if I come out a bit and try to get on a little better shaft. Yeah, that just does not run well. So we'll just go at it and cut that out. Does not run well. very true at all, but that doesn't matter because we're basically just cutting this thing off. But we're going to start back a ways and take some material off of this end to get inside of the weld so we can just push it out. All right, I'm going to take a little more. Well, I'm thinking we probably cut the weld. I'm in there a little bit, and we'll just take this back to the hydraulic press and try to pop it off. Look at that. Perfect. So I did something a little dumb here. I should have actually turned down the outside diameter on the end too to get it to go through well, but I don't think it's going to be a big problem. It pushed pretty easy. We'll just use this piece of bar stock and push it through the rest of the way. All right, perfect. We got it out of there. It looks like they didn't chamfer them welds, you know, the part at all when they welded it on. So we're not going to do that on the next one, so it'll be easier to change next time. And yeah, it scraped a little bit, but a little emery cloth will clean that right up. Doesn't look like this is a precision high-speed thing anyway, but that was definitely dumb on my part. I should have turned down the end of that shaft a little bit. But I think we're in good shape here. So now we got the shaft out. I'm going to measure where it was on the wheel, and it is 1.5 inches. So this thing, I think, is wore that much from time. So I'm going to go ahead and get a chunk of stainless steel ordered, and when that arrives, we'll make the shaft and put it all together. Okay, well, our stainless shaft just came, and I ordered ground stuff, so it's right to size, ready to go. We'll just face off each end and chamfer it and get it to length. All right, so we need to finish it at 14 1/4. So I will just get out my baby caliper. This is my 24-inch Starrett 123. I've got the 24, the 48, and the 72 now. And I've got 50 thou to take. 14,300. Actually 303, so 53 to take. And I know I was running a little fast for stainless there, so I need to change my insert now. Stainless is a material you run a lot slower on, just because it is harder on the tooling. All right, so I was running 487. I'm gonna actually knock it down to 180. All right, we'll just come in and touch it off. Zero my readout and we'll go in. I probably took about 2 thousandths on that touch off, so we'll just take 50 right now. That's looking a lot better. Much better. Okay, the next step here is to drill and tap this 5/8 11 hole. We're going to use a 1732 drill. We'll center drill it first, drill it, and then tap it, all using the anchor lube. Now, one of the secrets about working with stainless is slow speeds and heavy feed. Have a good push on it, but slow RPMs so you don't burn up your tool, and this stuff will cut just beautifully. All right, now the only problem with these old Monarchs is they don't have reverse. So you gotta back a tap out manually, which isn't a bad thing all the time. There she is, all tapped. Now we'll head over to the mill and cut the keyway. Okay, we're over here at the Bridgeport. I'm all set up. I just need to touch off on the end here and get my end mark, my end point. There it is. Zero the readout. Back it off, and I'm gonna take 50 in a pass for a depth. I'm running 210 RPM, and we'll just see how it goes. We'll get our anchor lube here. Put a little bit on there. All right, our keyway is cut. We'll just knock that burr off of there. And now we take it back, assemble, and weld the wheel on. All right, I got her back here in the weld shop. I got it up in my weld positioner so I can drive it. May need to speed my speed up just a little bit, but we'll get that all dialed in. I got foot pedal for the positioner on the left foot and the foot pedal for the TIG welder on the right foot. And I'm a little rusty on my TIG welding because I don't do this every day. So hopefully this comes out good. I'm going to keep the amperage down, trying to keep the heat out of it so I don't burn the rubber. I may stop halfway through and cool the thing quick just to not run the risk of doing any damage. So let's start welding. Well, that doesn't look all too bad, really. So I'm going to cool this off, flip it around, and do the other end. That one looks a lot better. Just takes practice to get good at this stuff. Well, there you have it, another job done, ready to go back to the customer. They brought this to me because the OEM said this was $2,700 for this little assembly here. And because the tire wasn't bad, they decided, let's see if it can be fixed. So, doing what I can to keep the customers moving forward and save them a little money, that's what this business is all about. And I think we're gonna have a very happy repeat customer here. So, with that, until next time, get out in your shop and get it done right the first time.